Hello.
Hello, Dr. Lengauer. How are you?
I'm good.
Good, good. Thanks again for agreeing to a Skype interview. We're really excited here. I just want to talk for about 30 seconds about our school. We're an expeditionary learning school in Rochester, New York, which is upstate New York between Buffalo and Syracuse. And we're a kindergarten through 12th grade school. We have learning expeditions in each grade level. And this fall, students have been learning about cells with our science teacher, Deb Hortensi, and a whole bunch of information related to that, as well as in language arts, they've been reading the book, The Immortal Life of Henrietta Lacks. And they're in the process of finishing up a magazine that has science information, social studies information, a lot of it connected to what they've been studying. So thank you for agreeing to meet with us. And these four students are going to ask you a series of questions, and we appreciate it.
Sure.
Okay, so good morning, Dr. Lengauer. My name is Rena, and I would like to ask you a few questions today.
Sure.
Okay, so how did you get the idea to create the fish technique for viewing cells?
Yeah. Started with a need. What we wanted to do is we wanted to somehow visualize the DNA, the gene of cancer cells, and that's very difficult because nobody has seen them ever. And we thought for a long time how one could do that, and this is how we came up with this technology.
Oh, hello, my name is Demi Davidson, and I would like to ask you a question. What type of chemicals did you use in order to create the fish technique, and why do the different parts of the cells turn into different colors?
The chemicals, they have all very complicated names, but what's important is that they all are chemicals that can be shown in different colors, like, stains. Those are fluorescent stains. You know them sometimes from those festivals, also when you get those green fluorescent necklaces or something, right? It's the same idea. Those are chemicals, and they have different colors. The challenge is how does one paint the individual chromosomes in different colors? And what one does is one links such a fluorescent chemical to the DNA of a human, and this DNA finds then its partner DNA in a cell. Finds exactly the same DNA in the cell and binds to it, sticks to it. And then this part of the cell, let's say, is green, and another part of the DNA that you labeled in red is then red. The trick is you combine a fluorescent chemical with DNA that's part of your genes, of your body, and that construct finds in a cell the DNA that is complementary, that's exactly the same one, and that's the way you say. Complicated.
Oh. Hi.
Okay.
What are your personal feelings about the way Henrietta Lacks and her family have been treated?
I think there are two types of feelings. The first one is, I think it has not been sort of fair that nobody really thanked them for a long time. And because somebody's cells give rise to so many scientific inventions that I think is something important, and the family lived so close to the Johns Hopkins campus where the cells were used, therefore it would have been so easy to say thank you. Therefore I think that's really a pity. That's the first feeling. The second feeling is, those were different times. And at that time, a physician, a doctor was still control of everything. Didn't have to ask for permission. If you take cells, you didn't have to ask the patient for almost anything. You just did what you wanted as a physician. Therefore, I think this first feeling I described, which is some feeling of, that they never were thanked the right way, and that this is unfortunate, needs to be put in perspective of the time. Times were different then.
Good morning, Dr. Lengauer. My name is Miguel Smith. I have a question to ask you. How did you become interested in oncology? What do you have to study, and what are your college degrees in?
Okay. I became interested in oncology because maybe like all of you, you might have somebody in your family who suffers from cancer, or you have a friend who dies from cancer, and people ask you, why is that? And I wanted to understand that. I wanted to understand why do people get and suffer from cancer. Because I saw so much suffering as maybe you do in your family. And then I wanted to not only understand it, but use that understanding to make new medicine against cancer. That was what drove me when I was, I think when I was 16, that's what I wanted to do. For that, then I had to go to college, to get a PhD. I had to be a professor at Johns Hopkins. I had to do more learning. I had to switch and move from different countries. From Austria originally, then I moved to Germany, I moved to the United States, and France, and to the United States again, because I want to have the best education. And I had to go to a lot of classes that I was not interested in, because I needed to get my degrees, and those sometimes require that you also have to learn things that you don't really care much about. I studied what's called human genetics, and I studied biology.
What do you think of the way medical research was conducted in the past? What kind of progress do you think we made in medical research today when it comes to ethics?
I think in the past there was this, I think doctors were so important and recognized, and that's why nobody questions their action. I think it was the same maybe with pastors or with, with maybe teachers at that time. There was much more respect maybe than there is now. And because the other people didn't have the same education or information. But this has changed, and you know it. Now when a patient comes to a doctor's office, the patient very often brings a pile of paper with him, because the patient printed it all out from the internet and asks the doctor of, why do we not do this treatment? Why don't we do that treatment? I have Googled it, I have learned about it, and therefore patients are much more educated now. And that has consequences. And the second thing is, one has understood that just patient needs to be one effect. And this has an effect on the ethics, which means now there is what's called a patient consent, that every patient needs to sign first before a physician or a nurse does a treatment. You know that when you go to the hospital and you need to get blood or something, your parents need to sign for you, because if they do not sign, the nurse cannot take blood for you. And this, I think, is important, because patients are not only, mean, physicians, doctors are not only very special or whatever, but so are the patients.
Okay. So if you could talk to Henrietta Lacks and ask her or tell her one thing, what would it be?
I saw that question. That's a very, I think it's a super question, but it's also a difficult question. I would, if it would be now, I would, I think, tell her about the impact of her cells, because, you know, remember, she died of cancer. I think. Same time, this cancer helped us to advance science, and without her, many, many more people would die today, because her cells helped us to make new medicines. And I think this is special. I would thank her for that.
Are there any other immortal cell lines, and have you worked with them as well?
As you know, a healer cell was the first cell line that became immortal, right? Before that, cells couldn't be cultivated, couldn't be, you know, couldn't keep them. Therefore, that's the special thing about HeLa. Now, your question is, are there more? Yes, now there are thousands cell lines, maybe 100,000 of cell lines that are immortal. Because from studying the HeLa cells, one understood why, we know now why they became immortal. And now we can do this with any cancer line and make those lines immortal as well. Therefore, now there are hundreds of thousands of immortal lines.
When you conducted research using HeLa cells, what are some of the controls you use? Do you use other HeLa cells or some other cell types or cultures?
Yes, it's the same thing. I use many of those. Right now, we are cultivating with a robotic system 500 such cell lines at the same time. And I do not have to do anything. And the robot works at night, works on weekends, and that robot cultures those cell lines itself. But those robots are very expensive. The one I talked about cost about $7 million, for example. For some of that research can be very expensive.
Okay, so why do you think the cells have made such an important impact in medical research?
So cells help us understand the disease. And that's always the first step if something becomes important. If it helps to understand something, then one can use this understanding and make medicine and vaccines. And that was the major impact. The HeLa cells, they help us understand how cancer works, and then scientists can make new medicines and vaccines.
Oh, sorry. So can all cancer cells essentially be immortal?
In principle, all cancer cells can be made immortal.
Wait, what?
Yes, right now, one can almost, the scientists cannot take almost every cancer line and cancer cell and make it immortal. That has not been the case maybe 30 years ago or 20 years ago. Really something that the scientists understood how to do, and we learned it from the HeLa cells, and now most of the cells can be immortal.
What is a culture medium specifically?
A culture medium is like the food, it's really sort of the food of cells. Okay? Cells also need food to survive. They need certain, what we call nutrients. It's like you need and I need, we need with vitamins, we need certain things to live. That's why we eat. And the same is true for cells. Cells eat some food, and that's what the fluid, the medium provides. There's a lot of complicated things in there. It's like when you open a box or whatever, it says in effect what's in there, right? When you eat something. That's the same with media. The medium. You buy this fluid or you make that fluid. There's a lot of things in there which the cells need to divide.
Okay.
Why did you enjoy working with her cells so much? And what is your favorite memory you have from working with her cells?
I like, but that's the same for other scientists. We like to work with inner cells because they can so easily be, they are so easy to work with because there are always so many of them. But that's a big advantage. They divide so well, and it's always easy to get a lot of them. Maybe my best memory is when they helped me and my group to find a cancer drug that is now working in patients.
We read about Dr. Gertler uncovering what was then called the HeLa bomb. Is this a major concern in laboratories who carry HeLa cells?
Yeah, what it really meant is that he had mentioned in a big meeting that a lot of his cells that he had had also, were not HeLa, had also HeLa cells in there. But there was a lot of what we call contamination, which means HeLa cells were not only in the bottle that said HeLa cells, they were also in the other bottles that had other cells in there. And that was a big problem because we want to have all those bottles in a clean way. Like if you have Sprite and Coke, you want to have in your Sprite bottle Sprite and in your Coke bottle Coke, and not sort of a mixture. And if you want to make sure if you buy Sprite that there's not a little bit of Coke in there. Right? And it's the same with cells. If you have HeLa cells, it should be HeLa only. And if you have another cell line, you want to have it only that other line and not something else in there. So it was a big concern. And it still is today.
Okay, so if HeLa cells contaminate so many other cultures and experiments, then why do the researchers continue to use them?
It's two different things. The first one, like this, HeLa cells are very useful to scientists because they divide very well and very fast. That's why we want to use them. But that has a danger. Like very often, good things have a bad side. And it's the same with HeLa cells. Because they divide so well, they try to go everywhere. Therefore, what we need to do is we need to protect the other cells so that they do not get HeLa cells into them. Which means practically when we open bottles, we need to be very careful and but still just saying those HeLa cells go somewhere else, not a good reason not to use them because they have so big advantages. So there are advantages, disadvantages, and the advantages are much bigger.
I understand that you met the Lax family. How did you feel about that?
It was an interesting experience because you have to know when I'm met the family, I didn't know all the things that are described in the book, right? I only knew that there was Henrietta who gave the cells, and now the children of Henrietta, and that they live very close to Johns Hopkins in Boston. But I didn't know much more. I didn't know the stories about the families, the other family members, and therefore, for me, it was most important to just meet them and thank them for, on behalf of their mother, for the contributions they made. Now, when I met after then I showed them all the cells, and you know that because I have a book. But afterwards, I for the first time thought about it. Once they had left, I thought like, maybe this was something very important in history. But I didn't think about it when I met them. But afterwards, when I thought about it, I thought, maybe that's too important.
Do you study any other cell cultures, or just HeLa?
No, not just HeLa. As I said, now we are studying, I would say just myself. I've studied and worked maybe with 1,000 different cell lines.
Okay, so that's pretty much it for the students' questions up here. Does anyone out there have a question that they'd like to ask Dr. Lengauer before we transition to the next group? Either related to the book, meeting the Lax family, or his work with cells and oncology. Brandon, nice and loud.
How long do you think it will be until we can find a cure for cancer rather than just treatments?
If somebody in the front could repeat the question, I couldn't totally hear because it's a little bit
nice and
of
loud, Brandon. Yell it.
How long do you think it will be until we can find a cure for cancer rather than just treatments?
Okay, that is a super question. You should know that actually there are some cancers that can be cured today. And that is also partially because of the HeLa cell. There are certain types of cancers that today can be cured of. But you're right, most cancers we can only treat and delay sort of the time before people die. That's also very important, but we want to develop cures for all cancer. And for some of them, we have already succeeded. Therefore, every year you will now read in the newspapers, see on TV that there's another cancer that can be cured, another cancer that can be cured. It still will take a while to have this under control because cancer is very, very complicated evil in a way. But many cancers can be cured already. It's a very optimistic information.
We have time for one more question. Anybody? Brandon, nice and loud. You gotta yell it loud.
How long did you initially learn about Henrietta Lacks? How long have you been working with her cells before you learned about her and her family story?
I started working with those cells at the maybe first year as a college student. And then I met but at that time I didn't understand what HeLa stands for. Then maybe 4 or 5 years later, I learned actually that HeLa stands sort of abbreviation for a name. As you know from the book, there were different versions of the name. Therefore, I didn't know. And then I really did not know that this was a family very close to Johns Hopkins in Baltimore, till I read a small article that Rebecca Skloot, the author of the book, had published. That was, I would say, maybe 10 years after I, for the first time, worked with
Let's give Dr. Lengauer a big thank you.
Okay, I actually have a question, which is, when you, because you did so much work on this, which I think is great, because I think first it's a very important story, and secondly, I think it's also interesting. And when you put this all together, you know what I think would be a good idea, and I could help you with that. I think you should show that work to Rebecca Skloot, the author of the book. I'm still in contact with her, and I think she would be really, really happy to see that. She has a big blog on the internet. She has like several ways of showing what students or other people have been doing, and I think she would be totally happy about your work. Therefore, if you are interested, I can, once you have finished, you know, the whole project, I would be glad to help you get in touch with Rebecca.
Thank you, Dr. Lengauer. What we're going to do, we have an exhibition night on, actually it's January 19th, and we will send you an invite. We realize that you're not, you know, in Rochester, but we do plan on sending you an invite, and we will send you at least a couple copies of the magazine that students have been working on. And we appreciate that you're going to take the opportunity maybe to send one on to Ms. Skloot. So.